Okay, so after the differentiation and the stationary points and points of inflection, we move on to our cubic function. So the cubic function comes in play after our stationary points and points of inflection, because we're going to see, like in the middle of our cubic function, we're going to have a point of inflection. Okay, so our cubic function formula, this should look familiar because we just did it in points of inflection. So with the cubic function, you're going to have a cube squared to the power of 1 and just your constant. Okay. So if a, and like this is the point where you'll only be able to see the form if it's increasing or decreasing from our function. Okay. So if a is bigger than 0, you're going to have a function that is increasing. So first it is concave down, then it's concave up. Okay. Then if your a is smaller than 0, negative, it's going to be a decreasing function, and then it will first be concave up and then concave down. Okay. And in the middle here, you're going to have a point of inflection where your concavity changes. Okay. So now a little bit more information. So the derivative of a cubic function is a parabola. So if you derive this once, the highest to the power of you're going to have is your squared. Okay, to the power of 2, and that you know is a parabola. So if you have a parabola, which is your first derivative, you will also see that if the parabola is negative, the cubic function would decrease. Okay, if the parabola is positive, the function would increase. Okay. Now, the x-intercept of the parabola, so your first derivative, shows where the derivative is equal to 0. Okay, so your x-intercept is equal to 0. That is also your turning point of your cubic functions. So these points over here. But please note, and we will work through an exercise, but please note that these two lines are not in line with each other. Okay. So think about your parabola. If I have it here now, my 2 x-intercepts would be in line because it's in the x-axis. So I'm going to get my 2 x-axis, my 2 intercepts, and then I need to put that function, that x-coordinate, back into my original one. Otherwise, I'm just going to find the coordinate for like my parabola, but that's not what I need. I need it for my cubic function. Okay. So with that being said, let's go into an example. So the example says, sketch the graph of fx equals to x cubed minus 4x squared plus 4x. Okay. Show that all stationary points intersect with the axis and the point of inflection. So first thing I do, I check is a bigger or smaller than 0? Okay, so is it an increasing or a decreasing function? So I check, no, it is bigger than 0 because it's 1. So it is increasing, and my shape will kind of be something like this. Okay. Next thing, I need to find my stationary points. So, like I said, my stationary point, which is also my turning point, will be with my parabola's x-intercept. So I derive it once to get to my parabola, which gives me 3x squared minus 8x plus 4. So for my stationary points, I need to equal it to 0. So if I equal this to 0, I'm going to do either a trinomial or I'm going to use my quadratic formula. And I highly recommend using your quadratic formula because you're less likely to make mistakes with that. Your quadratic formula you'll also find in your information sheet, so you don't have to worry about remembering it wrong. Please don't try to do it like from memory. Go to your information sheet and write down that formula. Now, if I do that, I get x equals to 2 over 3 or x equals to 2. Now, like I said, if I go put these coordinates back into my first derivative, which is my parabola, I'm just going to find that my coordinate is 2 over 3, 0, and 2, 0, which is my x-intercept for my parabola. That's not what I want. Okay, I need these y-coordinates for my cubic function. So now I could put first 2 over 3 back into my cubic function. Then I get for this, where my x is 2 over 3, my y is 32 over 27. Okay, or if I go put in my second value where x is equal to 2, I'll find where x is 2, y is 0. So my stationary points are 2 over 3, 32 over 27, and 2, 0. Okay. So now already I have my stationary points and I have my shape. Okay. Going on to the next part. So after I get my stationary points, I do need to know where my x and my y intercepts are. So always what we do is if we want the x-intercept, we let y be 0, and if we want the y-intercept, we let x be 0. This still counts for this function. Okay. So if I substitute y for 0, again I need to factorize. So in this one, all 3 has x's, so I take an x out, I'm left with a trinomial. I'm going to find that if I factorize this trinomial, I'm going to get x minus 2 bracket and x minus 2 bracket. So when I write that out, I'm going to have x equals to 0 or x equals to 2. Then I know my x-intercept would be 0, 0 and 2, 0. We already saw this one before with our stationary points, and that's perfectly fine. Okay. Now with my y-intercept, I'm going to make x 0. So already you can see if I times any of these with 0, I'm going to get 0. So my y-intercept is 0, 0, which is also my x-intercept. Perfect. Okay. So now we have our 2 stationary points. We have our x-intercept, y-intercept. We know our shape, but now we need to know our points of inflection. Okay. So how to get my points of inflection? My second derivative. So I'm going to derive it once, and I'm going to get to my parabola, which we already used. Then I'm going to derive a second time that gives 6x minus 8. Okay. So for the points of inflection, I need my second derivative to be equal to 0. So I substitute this in. I get 0 equals 6x minus 8. Take the 8 over, divide by 6, and 4 over 3x. 4 over 3 equals x. Now that we have the x value, we need the y value. So we substitute our x value into our original cubic function. Okay. So where I see 4 over 3 for x, I get 16 over 27 for y. So my point of inflection is 4 over 3, 16 divided by 27. Then, okay, so now I have my stationary points. I have my x-intercept, my y-intercept. I have the point of inflection. Now for the last part, I need to draw this. Okay. So my tip is, before anything, go plot in everything that you have. So you see I kept my fractions. It's easier to write, but do go put it into decimal for yourself to see where to plot it in. Okay, so first thing I did was I plotted all my dots, all my coordinates where it's needed, and then I looked to A to see what my form is supposed to be. Okay, so I know from the beginning it's an increasing function, and from there on I just drew. Please, please, please note that you need to put all your coordinates in. You need to name your axis as well as your function. This was my fx function. And that is, yeah, that's that. That's the cubic function.